Hello and welcome to the YouTube channel of AI with Vic, and we are into the third episode of Understanding NumPy. One of the subscriber had commented on a special episode request of vectorization in NumPy, so we will do that today. So the idea today is that we will understand what is vectorization. Basically, we will try to see the difference between Python loops and vectorization in NumPy arrays, and then we will have a comparison on time and space complexity. We will use different examples there. We will use the examples of polynomials, uh, and we will use the examples of matrix multiplication to understand the key differences between Python list and vectorization. We will try and compare them using time and space, like the time taken and the space used, like in terms of bytes or megabytes, whatever that is there. So let's get into it, and we will start with first understanding uh, the key difference between Python lists and NumPy arrays. Let's consider a list here, uh, like this, which is 1, 2, 3, and 4. Now in this list, let's say we want to perform this operation, like we want to multiply each of the elements by 2. So in Python list, how will we do it? Like for lm in L, we'll do, let's say x is equal to element cross 2, right? This is the simple operation in Python list, right? Now what happens in Python list is that each of the elements is stored in form of a pointer, like pointer 0, 1, 2, and 3 here. And since it is in a loop, each pointer is read from a list, and each pointer points to a PyObject. Now this PyObject stores this information, like the ref count operations, the type of the element that is there, like integer, float, and the actual value of the actual value that is here. Like let's say, for example, in this case it's 1, 2, or 3, or 4. For multiplication, in turn, it is called, our API is called PyNumber multiply, which again checks whether what is the type of the integer, like if it is int, if it is a type of int or float, right? Then it performs multiplication, and after that, again the result that you see here, again x, right, again is allocated a PyObject here for storage. So you can observe that all in all, like there are 5 PyObjects being allocated here, and this PyObject is not a very cheap structure here. It actually, this actually has requires memory, like I guess 8 bytes if I am not wrong. This again also requires a memory, let's say 8 bytes, and this again, like depending upon the depending upon like whether it's in 32 or 64, right, it this again ranges from 8 to 16 bytes if I'm not wrong, right? So this process involves a lot of time and memory, as you can observe here, right? But in case of NumPy, this whole list, or basically array that we declare here, is stored in a form of a raw C buffer. So basically in C, there is a buffer, like a large buffer has already been declared, like a contiguous one, and where we can store values like 1, 2, 3, 4 you have stored here. Now what happens is that there is a pointer, obviously, but it points to a PyObject, only single PyObject. Now this PyObject has the shape of the array, the data type, the number of strides if we want to take, and basically pointed to raw C buffer that we have here, right? So basically internally NumPy already knows that what is the type of the element here, like if it is int 32 type you have declared or int 64 type declared. Each time it does not goes and checks whether this particular element is of int 32 or 64, like it was doing here, like in PyNumber multiply, right? After that, what happens is that at the end here, this is basically the operation that I just said, that that the NumPy stands for vectorized operations, right, which is dispatched to optimized C code, which in turns calls the SIMD instructions, right? So SIM and the SIMD in SIMD instructions, like multiple values are basically executed in one single instruction. At the end, unlike you had in in Python list where the result was stored in PyObject, again here it is not stored. Here the output is directly stored in the large C buffer that you already have here, that you have already declared, or the C has already declared. So you can see that due to these differences that you have observed here, the NumPy is much more fast and extremely cheap in terms of memory. I hope this explanation helped you in understanding the rest of the video. So when we get into, after understanding that, let's first install a few libraries here. Like we are going to install the Pimpler library. The Pimpler library is basically will be used to monitor the time and the computation, right? We'll import few other libraries here like sysmath and other matplotlib libraries. So let's first understand how will we basically compare. Okay, so the idea is that we will first generate a random set of data, right? And let's see that how does that data look like. Like let's say for example, if I generate 1000 samples, right, random 1000 samples in the NumPy float 64, you can generate it in NumPy float 32 also, that's fine. And if you see, it returns in the form of list and array, right? 1000 elements for list and 1000 element for array also in kind of a tuple format. Right, if you have a look here, length, if you see, that will be 1000. You can generate 10,000 also, or any other elements, number of elements that you wish to compare. Okay, that's the first step. The other function that we will use is the time call. Basically we will try to compare the time, like various several times that we have. We'll try to compare the time for that, like start a wall clock time from here and usually call it at the end. Basically the idea is to compare the difference of time, like from when it started to when it end, a standard procedure. The other function that we are going to use is basically to compare the bytes in the array. So if you remember, in first episode we talked about item size and bytes of an array, right? How much what is the memory size of each element in a array. So let's say for example, if you have 1000 array here, and if we are trying to compute that for arrays, for NumPy arrays, let's see how that is. This is 16,112 bytes, right? If we convert that to float 32, it will definitely be less. Let's see that. Obviously it's less, right? So we will keep this at 64 and go ahead. Similarly for list also we will try to compute it, right? In case of list you can already see that it's quite high, right? It's 32,056 bytes. 32,056 bytes. The idea here is that let's talk about the testing. What are we going to do, right? The idea is that we will first test it using a polynomial. So what do I mean by the polynomial? I have declared a polynomial here, that which is of the form a, right, x square, right, ax square plus bx plus c, right? And these x are basically the random elements that we are generating here, like the generate from here, like 1000 elements, 10,000 elements. So this is basically y is equal to ax square plus bx plus c, and where I have fixed the value of a, b and c, like 0.5, 1.2 and 0.3. So for each input here, like for each input, like x is equal to, let's say for example 0.234, I will get a y value here, right? And that will be basically 1000 y values, or 1000 for 1000 x values there, right? And that will be done for both list and numpy, and we will compare the time basically that has been elapsed for computing for numpy, and the time elapsed that has been used for computing list, and similarly for the memory case also. uh, Now this is the function for computing the vector part. Like basically for numpy we will be using the op poly vec, and for the list we will be using the op poly loop, right? So here you will understand the key difference here. So let's say for example, like if I have op, I will just illustrate here, and if I have numpy array here, let's see, I will take this and put it here, and this is going to be an 1. You can see the values being computed here, right? Okay, I need to block this out. Just remove this. Okay, let's move to the other part. Now what are the now how do we compare that? So let's say for example I choose 1 2 3 4 four different sizes, 4 different basically random generation. Like for each of this here you will see a random generation here. So for 1000 you will see a generated data for list and array, and then we will call a time call function basically to compute the polynomial loop. Let's add one more here. Let's see if what does it happens if I add one more here. 10 yeah, let's see, 10, this is quite big, right? So 500, this is 0 here. Okay, let's see that. Okay, for each of the sizes what it is doing is basically generating data. It is trying to compute the polynomial loop for basically list, and then for polynomial basically for the vectorized operation in numpy array. Then it is basically it is getting the memory for the list and memory for the array, and it's appending a result here, compiling a complete result here. So basically for 1000 generated data, this is the time, this is the time taken by numpy vector, this is the time taken by python list, this is the memory used for numpy for python list, and this is the memory used for numpy array. You can see the difference here, right? Let's plot them, right? We will try and plot them. Okay, great. You can see here for the time taken by the python loop is immensely high here. Like it's getting like for the 10 to the power of 4 number of elements, 10 to the power of 5 elements, 10 to the power of 6, 10 to the power of 7, and for numpy vectorized operations you can see here it's quite less, right? Similarly for the memory also, right? You can see that for some time they were on the same line, but for larger like vectorized operations or larger data, if you have, like it's considerably very less, like it's just 150 MB, and for python list is more than 300 MB, you can see here, right? Now we will use to understand the dot product and the matrix multiplication also using the same process, right? For this is for the python list, for how we are going to compute the dot product, and then for the matrix multiplication. Matrix multiplication, if you are in BTech, or if you are in class 12, or if you are in higher studies also, I guess you might have done it in using your C or C++ or if you are learning Python also, you might have done that, right? We will benchmark again using the same set of data points here, right? And a bit different, but it's the same, right? uh, we'll first generate the data, we'll then call the time loop, and then we'll compare the bytes list, like basically the memory optimization against the list and the array, right? Let's do that for the dot right now. So you can see that for dot products in NumPy, we use np dot here, right? And you have got the timing record, right? For a dot product, you can see, like for the Python loop, it takes a lot of time. Like for a 10 to the power of 6, you can see the time taken, and for the case in the NumPy arrays, what is the time taken here? Like it's quite less, right? Uh, the time complexity is quite less here. Now let's move to the last, is basically where we will try to compare using the basic matrix multiplication, right? We will choose sizes of 64 and 128, right? And so let's see that. Mm, we have already declared the matrix multiplication loop function, and for numpy we will just use np.matmul. That's it, nothing more, right? uh, let's see. Now this is kind of a very like kind of profound result you can understand. It's pretty simple to see that in Python loops, and you will observe that it's the time taken is quite high, right? In case, whereas in case of numpy, you can see the time taken, right? It's just fraction, right? In case of multiplication of memory also, for n equal to 64, it's like you can see that it's the difference is not that much, but in case of n is equal to 128, difference is quite large here in case of like for the numpy arrays. Now you do understand that in deep learning and in deep learning going forward, or in machine learning or in AI, matrix multiplication is one of the most profound kind of operation that you will be performing. Like if you are trying to build an algorithm, or you are trying, if you look inside into the deep learning models like LSTMs or by-LSTMs, right? Or even if you go into the higher large language models like BERT, GPT-2, or other models that we have in place, matrix multiplication is one of the basic operations that you will perform. And in this case, like here, if you notice, like just for the size of 128, like look at the time difference here. Right, the Python is of if you want to compare in specifically in big O complexity, it's order of n cube here for the Python loops. It's quite profound here, right? uh, so yeah, so with this small experiment and the explanation between Python lists and versus NumPy arrays, you might have an idea about like why should we use NumPy arrays as much as possible, right? I hope this video helped you out in understanding that concept. I will attach the code also in the description. If you like this video, please like and subscribe. Thank you.